और थोड़ा सा, चलिए हाँ जी, आइए हम लोग आज लेट्स से, please let me know whether audio, video and everything is okay. Please like and share to your friends. Let me know whether it is audible, visible, clear audio. I am looking all the way fine, like audio and video. And can you see my uh, screen? Okay. So let me start with the class. Today, as you have seen here already thumbnail, you can see what is the topic we are going to cover. So please 1 minute. How is that all is okay? Okay, fine. So let me start with the basics. So in this class today we will be discussing about electric flux. I mean how will be the electric flux. Okay, so 1 second, let me check whether everything is clear. Just a minute, just a minute. Yes. Link can't load. What happened? What's the problem? Okay. Okay, all is fine, fine, fine. Okay. Okay, all is fine, fine, fine. Second. चलिए, we are here live and चलो आइए, let us start. Okay, so we are having the classes like chalo, please like and share, please like and share to your friends and all who can join here, and please comment whether my audio or video is clear and visible to you all. Please let me know it. Okay, fine. So here we will discuss about electric flux. The electric flux, now what is the electric flux? Basic first we will try to understand. Here our topic will be electric flux, and we will be covering for the electric flux and some practice with the question. Okay, so hoping everything is fine, like audio, video and everything will be fine. So let me discuss start whether is it buffering or any type of problem is not there. No? Please like video as well as share to your friend so that I can know, and please chat something, comment in the chat so that I can know audio, video and everything is fine. Okay, so our topic is electric flux. So I am starting with the electric flux. Here in this topic, in the electric flux, so first we will discuss about the electric flux. What is the electric flux? Electric flux means what? You can assume that actually electric flux means the number of electric lines passing through a closed surface. Means how many electric lines will pass through a closed surface will be called electric flux. Now here question arises, electric lines can be fraction. Question can be generally asked that electric flux can be in fraction, right? But electric lines cannot be in fraction. Like if I am asking you 6.3 Wherever is the electric flux, so what is the meaning of that? 6.3 lines are passing. So here concept we have to, it looks something different. Please like and share so that I can be able to, so that it can be reaching to the more of the peoples. Okay, so so what is the concern is we have a, okay, so electric flux means number of lines passing through the, number of electric line passes through the surface. So now let us assume here, suppose we have electric field E equal to let's say this is a y axis and this is the x axis. Okay, fine. And here electric field is a not into z direction. So what is actually electric field? First we need to understand that electric field is nothing but phi is the electric field is equal to d phi I am taking for a small flux, and this is nothing but electric field in dot product with the area vector. Both vector will be dot product and it will produce give the result as a scalar quantity. Okay, fine. So here we have electric flux phi is equal to E into dA, which is dot product. Okay, since electric flux is a scalar quantity, that's why here we are using dot product. Okay, fine. So electric flux. So now question arises that area is the vector. Yes, area is the vector. For more information about the area, we will discuss later, and if I will get free time, I will upload the video mentioning that how area is vector or scalar. Okay, fine. Here we are taking area as a vector. So this is the electric flux which we have, which we are going to discuss. Hello Ram Kumar, how is going? Video audio is fine, all is fine? Please let me know, Ram Kumar. Yes, okay, fine. Yeah, okay, fine. Chalo. Okay, so here this is the electric flux. So if I am asking that what is the electric flux, electric flux means if I am talking about the small flux, small flux means this will be electric field and electric field vector and dot product of area vector. Okay, this can also be written as d phi is equal to E dA cos theta. And what is the theta? Theta is angle between electric field and area vector. Electric field vector and area vector. What is? Okay, this is electric flux. Now, if we talk about the electric flux, let's say we are assuming one. Talking about one, what is the electric, 1 minute, what is that? This is the dot product. Okay, the dot product of two vector will be a scalar, that's why I am using here dot product, and this flux is a scalar quantity. Please like the session, those who are attending. This is not receiving enough video in maintaining a smooth system. Okay. Okay, fine. Okay. So let's say let me discuss about the question. Suppose that here number of here we are taking one surface. How is going? Is fine. Okay, so here let's say electric field, electric flux which I have discussed, electric flux, let's say phi is the electric flux, and this small flux I am taking elementary flux, and this is a E into dr. And if this is a uniform electric field and we want dA, if we want to find the total electric flux, the total electric flux will be integration of d phi into E dA. Am I right? And if we integrate, if it is a uniform, if electric field is uniform everywhere, if it is a uniform, then this can be written as this will be phi will be E dot A D, this will be outside and integration of area, right, this dot product. And here, where is it? Okay, so here you can say that phi is nothing but E into dA vector and its integration dot product. This will give you a flux. Okay, if electric field is uniform, then this integration will be the area, means total area, right? That means be E into A, E dot A, and it will be a cos theta. The flux will be this EA cos theta. Theta is again angle between electric field and area vector. So now let's consider with the example. Suppose that this is a one shape I have taken, this is square, this is x axis, this is y axis, and electric field is in z axis. Let's say E equal to E naught K, one electric field which is in the z axis. Okay, and now we want to find its electric flux. So how will you find the electric flux? Let's say this length is A and this is a B. Okay, fine. Now the electric flux is just out this way, is a direction, and area vector will, how will you take the area vector? The area vector will be this way only. This is a square, this area will be this is a rectangle, and this area direction will be this. So angle between them will be 0 degree. So here flux can be written as E naught into area. What is the area of this shape? Area is A into B. So this is the electric flux through this. Let's say another example, if I am talking about the same this area electric flux. Suppose this is, what is this? Electric field is, let's say again, E naught into K cap, and we need to find this area, and let's say its radius is R. How will you find the electric flux? And this is the y axis, this we are taking as x axis, and here outward you can see that outward in this direction this will be z axis. So can you tell me what is the area? So what will be the electric flux? So here electric flux will be, how will you calculate the electric flux? Here electric flux will be again phi can be written as E into A. Here in cos theta, theta is here 0 degree, so it will be 1. So electric field is E naught into area of a circle is pi r square. This is the flux. Okay, fine. Let's say if here we have discussed when this is the electric field direction and area vector direction is in the same direction. Let's talk about this. If vector angle between them will be something different. Let's say here is a circle and his radius is, let's say, r. This is the radius r, and this is the electric field direction which is uniform electric field, and this angle, this is a area vector direction, and this angle is angle between area and electric field, let's say theta. So how will you find the electric field? Electric field actually is, here will be E into area of the circle will be pi r square, capital R, and cos theta. This will be our electric flux. Okay, let's say one more example with that. Another example, let's say, suppose you have one circle here. Yes, let's say you have one circle, and in this circle, if electric field direction, area direction is this is the direction of area, and electric field direction is this. Okay, and this angle I am giving you, let's say 30 degree, and this radius is, let's say, r. What will be the electric flux? Here electric field is E. The here electric field will be again written as E equal to flux equal to E into area. Area is pi r square into cos 30 degree. This will be the electric flux. Fine. Okay, fine. Everything is going good. 1 second. Yes, it is going good. All is fine. Everything is fine. Okay, now let me discuss about what will happen if it is not uniform electric field. So question cannot be like a uniform always. Question can be like a non-uniform. Let's say electric field here is let's say suppose this I am taking as a x-axis. 1 minute, let me draw clear this diagram. Let's say this is a x-axis and this is the y-axis. I am taking it as a y-axis. Okay, fine. And here is a rectangle of side length. Let's say this is A and this length will be B. Okay, fine. And suppose electric field is E naught into x k cap. Electric field is outside, but it is a variable. It is a variable. Its direction is along the z axis, but as you are going from the origin toward the x axis, then here electric field is varying. In this case, how will you find the electric flux through this particular question, this particular shape? So please everyone take a pen and try it. How will you find it? Okay, let me find. Here electric flux can be written as, first of all, what we will do, we will take a small length here, let's say here to here, let's say x distance, and this we will take as a small length dx. Fine. And due to this small element, we will find the first electric field, electric flux, and then we will integrate for finding the entire. So let's say if this is a d phi, can you tell me flux, what is the area of this strip, this particular small strip? What will be the area? So here a small area, let's say dA, I am representing as a dA. So dA will be written as length into breadth. This length is b and breadth is dx. So this will be the area. This is the one small part, this length, and this is like a rectangle, a small strip. Okay, this is the area, dA area. Now we know flux is equal to, what is the flux formula? E into A dot product. This is an integration. This is what we know. So this is dA. Okay, this is what we know. Now I am going to find first of all, let me know what is the angle between electric field and area vector. Can anyone will be able to say the angle between electric field and area vector? Angle between electric field and area vector? Yes, angle between electric field and area vector will be 0 degrees. Why? Because see, this is our rectangle and its direction will be in this direction, along the z direction, and electric field direction is also in this direction. So angle will be 0 degree. So here I can write here electric field for this small particular length will be what? E naught at x distance is x, and area is b dx, and angle is 0. So I now need to write here and integrate it for getting the total flux. This is a small flux. Okay, so now if we integrate from where to where, I am writing again, once again this equation I am writing here clearly. Phi can be written as E naught into x. E naught into x is the electric field at x distance. Electric field B naught into x, and area is b into dx, and angle is 0 degree. So cos 0 is this is dx. Cos 0 is 1, so no need to write, and then integration. Now we need to integrate from where to where. So now you can see here is a variable x, and x is varying from 0 to a. X is varying from 0 to a. So this will be integrated from 0 to a. And this, if you integrate, then it will be E naught into x, E naught into b. This is the constant which will come outside, and it will be x dx integration from 0 to a. And finally you will get, if you integrate that, E naught b into x square by 2 and upper limit lower limit 0 to a. So what we will get that here I am writing flux, you are getting that E naught B into x square by 2 upper limit 0 lower limit a. This is what we are getting. Now we have to substitute the upper limit lower limit to get the value, and we are getting E naught B into a square minus 0 by 2, and finally we will get E naught into B a square. This is our electric flux through this. In this case, this is the electric flux. So here process is important, answer is not important. Important in the process how we are finding the electric flux. Okay, fine. Now let me discuss about the case when electric field is this. Can anyone answer this? And I am mentioning here once again, I need to mention that let me mention this particular axis is x axis, and this axis I am taking as a y axis. This is a x axis and this is a y axis, and this is our rectangle. This is a rectangular shape, and here is how many what is the electric flux passing through this rectangular shape. So here I am taking one thing, that this length I am again taking a, and this is taking again b, and our electric field is this is in a space in all direction, x axis, y axis, z axis, all direction. How will you calculate the your electric flux? Interesting. So first of all we should see the component, this component along x axis. Now see, 1 minute, just try to understand. Electric field, let's say this is a x direction, electric field in this direction. For I am talking about this component, talking about this component. This is the electric field, and this is my particular direction of electric field, sorry, area vector along the z axis. Area is along the z axis, and electric field in this direction, angle is how much? 90 degree. So electric field here will be due to angle will be 90, so this will be 0. Similarly about the y axis, this is j cap. J cap means vector electric field along the y axis, and direction of area is along the z axis, so angle is again 90, and this will be again electric flux 0. And now we have electric flux in the z direction. Now electric field direction and area vector direction are same. In this case, how will you calculate? The same case, it is coming, electric field is coming E naught into x k cap, and the same case what we have discussed before here. So this is the same case, what you can see that electric field was this and area vector was this. So answer will be exactly the same. See here. So I am not going to derive this all. So this will be the our area. Okay, now one second. Okay, fine. So this is what we have already calculated. This is our calculation of electric flux. Now let me discuss about this. What will happen to this shape? Now I am saying you once again I am again telling you, the electric flux means the number of electric lines passing through a surface, closed surface. So now let's say if electric flux is passing through this way, and electric lines are coming outside from this way, this shape. So what is the electric field here? How will you calculate this type of shape, electric flux? 1 second, just a second. Please let me know how is the audio and video, so that I can be, if anything required, I can be able to rectify. If anything required, please let me know, I can be able to rectify. Okay, now let me again proceed toward the this, where is it, where yes, here Yes, here we have to discuss the electric flux. Now try to understand in this shape. If I am talking about okay, YouTube is not in a video containing a smooth thing as soon as such you are expressing. Okay, streaming bit is higher than recommended rate. Okay, okay, fine. So here you try to understand. Here this is this shape. This I am talking about this face A, B, C, D. If this particular shape, and here electric field direction is this is the electric field direction, and area vector direction is this. Am I right? And here electric field direction is this, and here area direction is this. Am I right? So here flux, if I am writing flux in, flux which is going inside will be area electric field into area, and it will be minus. Why? Because angle is 180 degree. And here flux will be, if going out, how much it will be? It will be electric field into area, and this will be this will be positive. Why? Because angle is 0 degree. So here cos 0 will be 1. So in this case this will be the situation. This suggested that is buffering or what, any type of things are there like buffering and all, not receiving any smooth. You not what something I can't understand what is. Okay, fine. So here is a area vector, and here electric flux will be this. So let's say if I am talking about any particular shape here, this is a let me take this. Suppose this is a one shape, and this is a circular, bottom is a circle, but outside I don't know what it is. And if you have to find the, suppose the electric field direction is this, how will you find the electric field here, electric flux here? So suppose electric this area is, this radius is, let's say r. Okay, so how many electric lines are going inside? So in this will be here electric field direction, it will be area vector direction is this one. So electric field direction and area direction are just opposite to each other, means theta will be 180 degree, correct? So flux in, phi in will be negative. And so how will you find the electric flux going out? To see going out shape is not defined shape, is not regular shape. So in this case we need to do integration, and we cannot perform the integration in this shape easily. It requires a lot of stuff to do. But how will you find? So can we tell me that if suppose this electric field strength is E naught, so and radius is r, then here I can write here flux in, flux which is going inside, it will be how much? So this can be written as of E naught into area. Area of the circle is pi r square. Super. And flux going out how much? Don't know, or we don't know how to calculate. For calculating just we need integration. Can you tell me the net flux? Phi net how much? See what, how many electric lines are entering? All electric lines are going out. So how many electric lines are being inside that shape? So 0. So net electric flux will be 0. That means net electric flux is 0. It means that flux in plus flux out will be 0. That means here is 0 is equal to flux in, and it is minus. This is negative. This is negative. Am I right? And here is flux out. So we can write here flux in equal to flux out. That means outside going flux will be equal to E naught pi r square. This will be the electric flux which will be going outside. Okay, so I am